check how we can discuss the magnetic property and say like that we can predict the hybridization of some molecules using valence bond theory. For example, the first one is CONH3 6 times. CONH3 6 times 3 plus. Okay. Hexamine cobalt 3. Ready? Here the central atom is cobalt. Cobalt having atomic number of 28. 28 and moreover actually cobalt having atomic number of 28, fine. And here the cobalt is in plus 3, right? Yes. If the cobalt is in plus 3, what will be the configuration? It is argon 1s2 2s2 2p6 3s2 3p6, right? Followed by 4s2 28, the configuration is argon 4s2 3d8. If it is CO3 plus means argon 4s is dropped by 2 electrons and one more electron from the 2 electron from 4s is dropped since the last electrons are ionized because 3 electrons we wanna drop, right? This is a 28, so 2 from here and 1 from here. So the final configuration is 3d7 actually. Ready? And 4s is 0, 4p is 0 there, 4d 0 also there. Okay, fine. So now consider this 3d7. 3d7 is like this, right? And 4 is 0. What about the strength of ammonia? Ammonia have little bit strength, right? The ammonia have comparatively greater strength because CNOx is the order, carbon followed by ammonia. So ammonia have comparatively high strength. So fine, what about the case? Since amine is a strong ligand, it can able to pair the electrons. This is a 3d7, right? It can able to pair up the electron. Able to pair up the electron means actually iron, cobalt, nickel. I'm sorry. There is something wrong here. And the wrong one, that is, I'm really sorry. Here is a mistake. Cobalt actually 27 electrons are there. 27 electrons. So this is 4s2 3d7. If 2 from here, 1 from here, remaining is 3d6. 3d6 means, listen, this is also unpaired, fine, that's all. So this is not 28, fine. Listen carefully. So amine is a strong ligand which can pair up the electrons. Which means this is paired with this one and this is paired with this one. So here will be like this. So that there is 2 d orbitals are there and an s orbital, 3p orbital. So this is the case. D2 sp3 hybridization. D2 sp3 hybridization. For the unpaired electron is 0. So this is diamagnetic. D2 sp3 hybridization, unpaired electron is 0. So this is diamagnetic. Okay, fine. The next. I think this is okay. Like that. If I have CO F6 3 minus. The very same cobalt minus 6 plus 3, cobalt is still in plus 3. Cobalt plus 3 means argon 3d6, 4s0, 4p0, 4d0. Where F minus is a weak ligand. F minus is a weak ligand because that is halogen. Since that is a weak ligand, that weak ligand is not able to pair up the That's a weak ligand. So that is not able to pair the d electron of central atom, inner d electron. So it easily use the outer d orbital for its hybridization. Okay, so it simply use the outer vacant orbital. I'm sorry. Listen, outer vacant orbital means this is d, right? So it easily use the s orbital, 3p orbital, and 2d orbital. To that to that particular sp3d orbital, your ligands F minus can bring 2 electron to form that complex. That is actually exactly discussed in VSEP theory. So this hybridization is sp3d2, where 1, 2, 3, 4. 4 electrons are unpaired, n equal 4. Okay, n equal 4. So that molecule is paramagnetic. That molecule is paramagnetic. So you can find the magnetic moment. Magnetic moment, that is root of 4 into 4 plus 2. Root of 4 into 6. That's equal to root 24. Root 24. The answer is 4.89. 4.89. 4.89 something. So 4.9 is enough. Okay. So wait, I'll give you an idea. Using root of n into n plus 2. If n is 1, it will be root 3. If n is 2, it will be root of 2 into 2 plus 2. Root 8, I think. 2 into 2 plus 2. Root of 2 into 2 plus 2. 2 into 4, root 8. If n is 3, that is 3 into 3 plus 2. 3 into 5. 15. If n is 4, 4 into 4 plus 2. 4 into 6. 24. If n is 5, 5 into 7. 35. And the answers are, this is 1.73. This is 2.83. This is 3.87. This is 4.9. This is 5.91. Okay, so keep it in mind. This is important. So here the number of unpaired electron is 4. So that's paramagnetic, the magnetic moment 4.9. Ready? So the next molecule that is NiCl4 all of 2 minus. Okay. Here the atomic number of nickel, iron, cobalt, nickel, atomic number of nickel is 28. So the configuration of nickel is actually argon 4s2 3d8, normal configuration. But here chlorine minus 4, so nickel is in plus 2. So here the nickel is in plus 2 oxidation state. Plus 2 means argon followed by, so 2 electrons are dropped, which is dropped from the 4s, dropped. So 3d8 will be the, 3d8 means this is 3d8 and 4s 0, 4s is vacant and 4p is there. If the fourth orbital used, 4p is there, 4d is also there, 4d is also there. Ready? Here the coordination number is 4, right? So either it is sp3 or it is dsp2. What about the nature of ligand? The ligand is Cl minus. Cl minus is a halogen. Halogen is a weak ligand. So this is not able to pair up the electron. So this simply use the outer orbitals, where outer 4 orbitals are 1s and 3p's. So it undergoes sp3 hybridization to form the shape as, to form the geometry as tetrahedral. sp3, the geometry is tetrahedral. Ready? Since there is 2 unpaired electron, n is 2, the molecule is paramagnetic, and the Bohr magneton, if n is 2, the Bohr magneton is 2.83. Magnetic moment is 2.83. And fine, that's all. So what about the next? NiCN 4 times of 2 minus. Once again the very same nickel. Nickel is in -4 +2. Nickel is in +2 oxidation state. So the configuration of nickel is argon 3D8 4S0 4P0 4D0. Where Cn minus is a ligand where the donor atom is carbon. Carbon means it is a strong ligand. So strong belongs to strong ligand. So it can pair up the inner d orbital, inner d electrons. So it can pair the inner d electron. So let's consider the 3D8. This is the configuration 3D8 and the 4S, 4P, 4D. This is a strong ligand, so this can pair up the electron. So this is paired to here. This is paired to here. So there is one orbital vacant in D. And a 4S, 3, 4P followed by Ds. So it is better to use these orbitals. Okay, because one inner d orbital is unpaired. So it uses that orbital to form dsp2. Okay, so the shape will be square planar. Square planar. Where the unpaired electron N is 0. Because that paired the complex. Paired the electron. Like that, the next is NiCO 4 times. Nickel tetracarbonyl. All of charge 0, carbonyl have 0, nickel have 0. So nickel is in 0 state. Nickel is in 0 state means it is like argon 3D8. And 4S2 is there, 4P is there, 4D is there. Carbonyl, the donor atom is carbon. This is a very strong ligand. Carbonyl is a very strong ligand. So it pairs the inner orbital. So inner orbitals are paired. So this becomes 3D10 as this one. And 4S is vacant. 4P also vacant. Where the coordination number is 4, so it requires 4 vacant orbital where the hybridization is sp3. So the shape is tetrahedral. Okay, where the n value is 0, so this is diamagnetic. These are the 5 examples which is mentioned in the textbook. Okay, so we can consider more and more examples about this one. We can consider more and more example about this one. Okay. So my next example, that is ZnNH4 2+. Before that, COCl4 2-. COCl4 all of 2-. COCl4 all of 2-. Okay, fine. Central atom cobalt with atomic number 27. Configuration argon 4s2 3d7. Now check the oxidation state. This is -2, this is -4, so this is +2. So cobalt is in +2 here. So argon 4s2 3d7 will be there. Is it 5? Yeah. 3d7 means okay. 4s is vacant. Coordination number is 4. But Cl minus is a weak ligand. Since the Cl minus is a weak ligand, it can't pair the electron, right? So it simply use what? The outer orbital. It can't pair the electrons. So it simply use the outer orbital to form the sp3 hybridization. To form the sp3 hybridization. And what about the unpaired electron here? sp3 hybridization, the geometry is tetrahedral. Okay, the unpaired electron n equal to 3, right? If the unpaired electron n is 3, then what is magnetic moment? If n is 3, that is 3.87, right? 3.87, okay, fine. So that's how you can predict the shape, geometry, magnetic moment like that. The next is Zn ns3 4 times all of 2 plus. Zn ns3 4 times all of 2 plus. Ready? Ammonia is a strong ligand, right? Yes. So what about the zinc? Zinc with atomic number 30. Zinc having atomic number of 30. 30 the atomic number, fine. Now, configuration argon 4s2 3d10, and consider the charge of zinc. This is 0, so zinc is in 2 plus state, so perfect. Argon 3d10 4s0, 3d10 4s0. 3d10 means that's fully filled. Four 0, and the coordination number is 4, right? And amine is a strong ligand, fine. It's a strong ligand, but there is no electron to pair, right? So that strong ligand still can't pair the electron because the electrons are already filled. So it can use the 4 outer orbital for hybridization. So this become sp3 tetrahedral, sp3 tetrahedral diamagnetic. So we can't predict that if someone have sp3 orbital tetrahedral, it is diamagnetic, because in case of NaCl4, the geometry is sp3, it is paramagnetic, it is tetrahedral. Okay, we can't predict in a general pattern. Sometimes you can predict in a general way, but it is better to find their hybridization, shape, number of unpaired electron and magnetic property once drawing the diagram. Okay, so moving to the next example, that is Pt NH3 twice Cl2. Pt NH3 twice Cl2. Okay, fine. But the central atom is platinum. So what about the atomic number of platinum? Palladium, platinum. Palladium, silver, cadmium. Platinum, gold, mercury 8. 78 is the atomic number of platinum. 78. If the atomic number of platinum is 78, the configuration is xenon 54. Xenon 54. Fourth period is over. Fifth period is over. 6s2. 56. 4 of 14. 16 is over. There are 8 more electrons. That is in 5d10. 5d8. 5d8 is the configuration. 5d8. 5d8. 6p0 and 6d0 is there. Ready? So you should know how to design the electronic configuration. And platinum, this is in -2, this is 0, this is hole is 0, so platinum is in +2. Since platinum is in +2, these 2 electrons are ionized. Okay, so xenon 4 of 14 followed by 5d8. 5d8 is like this. And 6p 5d8 6s, right? It's not 6c. 6s 0 is the, and 6p. So it is clear that this is strong ligand, right? Here there is a strong ligand amine. A weak ligand chloride is also the strong ligand amine is the. So that strong ligand pair up the electron to become 5d8 like this. There is 1d orbital vacant, and they can use s6s and 2p orbital also. So that will be a dsp2 hybridization. Since there is a dsp2 hybridization, this will be a square planar one. Square planar one. Okay, square planar one with a geometry of what? Square planar one, where n is 0. Fine, that's all. Unpaired electron is 0, diamagnetic. Okay, fine. Now we can discuss more examples in the next part.